Welcome
to the joy of coding.
Hello and welcome to episode 164 of The Joy of Coding. My name is Mike Conley. Welcome to the stream. We're going to be hacking on some Firefox stuff today. I'm just getting over a cold, so my throat's a little wrecked. I might have to end a little bit earlier than usual because my throat's still kind of getting itself sorted, but welcome. Thankfully, over the the magic of the internet, well, I think I'm past the contagious stage. I've been working from home for the past couple days and trying to rest up as well. And so I think I'm past the contagious stage. I feel myself getting better, so I came into the office today, and thankfully through the magic of the internet, there's no chance of you getting sick from me through these pixels. Fingers crossed, anyways. So, but I don't think I'm contagious anymore. But who even knows? What does that even mean to not think you're, like, when people say, oh, I'm past the point of being contagious, how do they really know? That's what I'm curious about. Let's get started. Hi, we're going to be hacking on Firefox stuff. It's episode 164. It's January 30th, 2019. Last day, I think, or maybe there's one more day of the month. I'm not sure. But we're at the very end of January, the first month of 2019. A reminder, no plan survives breakfast. None of this is planned. None of it's really scripted. In fact, a bunch of this, I think, is kind of out of date. Yeah. So I'm going to actually remove a bunch of these. Because I have another thing I want to try and do, but I didn't actually update the notes, and I probably should have. Speaking of the notes, I want to let you know that the agenda that we're looking at, this thing right here, is something that you have access to. If you're watching this on Air Mozilla, it's in the handout section over here. If you're watching this on YouTube, it's in the video description down below. And if you're watching this on Twitch, then allow me now to, whoopsie daisy, drop the link into the Twitch chat as we speak. Here we go. Agenda. There's also a link to rate this episode in the agenda. It's here highlighted in yellow. I'll also drop a link to that in the Twitch chat. And you can let me know what you thought of this episode. I read all of the feedback that comes in, and it helps me to make the stream better. I also want to give a quick shout out to the episode guide, the viewer-driven episode guide that is completely viewer-driven. It has a bunch of notes, links to the streams, links to the agendas, addenda, topics that I covered. And if you yourself want to add your own notes to the episode guide, please send me a pull request to the repository. And if you're not sure what I mean by that, these links in the agenda should hopefully help. There's also a guide for creating pull requests, a contributing guide for the episode guide itself, as well as a guide for creating pull requests that SmurfD uses and recommends. And SmurfD is a prolific contributor to the episode guide. All right, so today, is everything working? I think so. I am recording. You can hear me. I'm not dropping frames, and I've got sound effects. Yes. Then let's get into it. What do I want to do today? Well, there are two things I was hoping we could take a look at. One is, this is an issue that we had looked at a couple of weeks ago, maybe late last year, which is finding a way to persist activity stream DOM content to disk at shutdown and load it on startup. And this is something that I think will really help with perceived performance startup, or actual performance startup, for startup, I should say. And so that's the thing I want to maybe look at today. Paste. I'd like to paste without formatting, please. Paste. Man, why are you underlined? Ununderline. And then I'm going to link that to the bug itself. And then the notes. I think I have some notes for this. 1497996. 1497996 is right here. And I took some notes last time, and I should probably quickly go over those and get those in my head, and so that we're kind of caught up and you can go, like, catch up with me. So unfortunately, that's what happens sometimes. You work on a bug and then you drop the bug and then you come back. Thankfully, with notes, I can kind of fast forward myself to where I think I need to be. Now, where this is blocked, like in the event that we get blocked on this, there's something else I was hoping to look at. I'm working on this feature, this new feature for Firefox that we're hoping to get up to beta sometime in Q1 called Video Picture in Picture. If this is a thing that you, maybe you were a test pilot user and you remember MinVid, this is a built-in version of MinVid that we're hoping to ship soon. In sometime, at least a beta in this quarter. And one of the things that we're hoping to do is, well, one of the things that we need is the ability to clone a video, or like clone from the perspective of the user, clone a video between two streams. And so there is a bug to do that, and I'm hoping maybe we can look at that today. I was talking to one of the graphics engineers, and I think we might have to do a little bit of studying to understand how it all kind of ties together, and we can look at the chat I had with him, with that graphics engineer, and maybe we can figure it out ourselves, a strategy moving forward. But first, let us talk about this this persisting activity stream on shutdown. Well, let's maybe start by reading the notes I have. So what did I write? I wrote, can a service worker intercept requests to about new tab in the privileged content process? Can a service worker cache arbitrary data, not just the page as it is, since as it is, the activity stream HTML document is very barren and likely not worth caching. We want to cache it after it's been rendered. It seems that there's a relationship between service worker cache and fetch. Putting arbitrary values is fine, but they'll only be retrieved from the service worker cache on fetch. It seems as if service worker cache and fetch are pretty tightly coupled to HTTP. Each other I find very unlikely we can just jam arbitrary strings into the service worker cache. There are other storage mechanisms we can use. Local storage, which is sync and can jank the main thread, but Peter B likes it and Aseth likes it less. IndexedDB is async and can handle blobs. Imagine we're finished rendering activity stream. The state is up to date and all is well. On idle, suppose we grab a copy of the document body, inner HTML, and we jam it into IndexedDB. Then suppose the next time about new tab, one of the first things it does is it tries to open IndexedDB and get at any pre-existing caching. If it exists, splat it into the DOM immediately, hydrate, and then wait for state updates. Otherwise, ask the parent for the state and do the rendering, maybe optimize the base case later. And then an idea came back in from one of the viewers of the stream and said, how about taking a screenshot of the page content and use an image map for the clickable elements till the React stuff is booted up. Now, one of the problems with doing the screenshot idea, we've played with the idea of using screenshots before, and that has to do with window size or display resolution, because we might take a screenshot and then shut down the browser, and then when the browser starts up again, it might open on a different display with a different screen resolution, meaning that the screenshot will be the wrong dimensions, and so that will look pretty awful. Mib N550G8 says, I love what you are doing. Well, thank you. I love what you are doing, which is chatting with me in the live hacking channel. How about taking a screenshot of the page content? So I'm reluctant to take a screenshot unless the DOM persistent stuff really doesn't work out. So one of the things I want to look at is the startup cache. So the startup cache is this component, startup cache, that we have inside here. Let me pump up the font. That we have inside of the inside of Gecko, and what it does is it knows how to cache various things during startup. One of those things it knows how to cache is like resources that we usually load from a jar, and then we compile it into some kind of bytecode representation, like Zool documents and XBL bindings. Once they're parsed, are turned into this binary representation, and because those tend not to be changed from session to session, they're static and they're loaded from the OmniJar, assuming no updates have been applied, then we can cache those binary representations in the startup cache, so that next time when we start, we can load quickly. We can skip the whole parsing step, and I think that's one of the responsibilities of startup cache. So one of the things I wanted to do was how does startup cache work, and does it work in a way that activity stream can take advantage of? Now there's some prior art here because activity stream already takes advantage of the script preloader. And the script preloader, I don't think, uses the startup cache, or does it? It pays attention to some startup cache stuff. But I think the script preloader manages its own cache file, whereas the startup cache, I think, uses the startup cache uses its like some kind of like there are two different caching mechanisms, unfortunately, and the startup cache does its own thing from the script preloader. So I'm curious about what the startup cache does. So where is the startup cache initialized? It looks like it's initialized whenever we init the singleton. We init the singleton whenever we get the singleton, probably, unless we've disabled the startup cache. So who says get the singleton? Anytime we're like, we want to read some bindings, or we want to read the Zool prototype cache, or the subscript loader, or anytime we're initting xpcom2. So this happens pretty early on in the browser lifecycle. When we init xpcom, we'll, right after the script preloader singleton, we'll do the startup cache singleton. So before we've really done, like, even entered the main loop, I think, or before we've even started polling for events from the user, we'll like initialize the startup cache. So what does the startup cache do when we initialize it? We get the jar protocol handler. Oh. What? Oh, sorry, I thought we were returning. So, no, we get the jar protocol handler, and then we get the Moz startup cache environment variable, and we make sure that there is one. Or we check to see if there is one, because if there is one, then we can like override the startup cache with our own file. So if there is one, then we get a handle to that file. Otherwise, we look inside the profile LDS, which I'm not sure what that is. Let's see if we can get a sense of it. File IO. LDS. Well, prof LD is local settings on Windows where the network cache and fast load files are stored. Let me bring this up here. Prof D, prof LD, local. So let's look for prof LDS in the directory service. A directory service key which specifies the profile directory, unlike prof. Is prof LD still here? Prof LD. No, it looks like prof LD may have been like supplanted by prof LDS. No, I'm wrong. I'm wrong. Originally NS app user profile local 50 dir is prof LD. And this is like a slightly different, because this key may be available when the profile hasn't been started or after it's been shut down. Okay, so this is a special directory that exists outside of the profile, which is handy because regardless of whether or not we have a profile, like it's the browser is probably like not been updated for, the browser is never updated for one profile or another. We have one particular install, and this install knows about this like special directory for itself, for this version of itself. So that's what we're getting here, is a directory that's outside the main profile directory. So we get at the file But then we go ahead and get the profile directory. Oh, that's in case we find that we're still storing the startup cache in the main profile directory, in which case we remove it. So there's some old code here where we used to remove the old startup cache. And then we append native startup cache, and then if we create the directory if it's not there yet, on the main thread I should point out, and then we append the name, the startup cache name, which is startup cache name is startup cache dot, and then some special characters depending on how many bytes per word. And so it's like we encode the endianness and bytes per word inside the file name. That's handy. And then we create the file. So assuming we have the file, we get the observer service, and then we create a listener object. So we have this thing called a startup cache listener. I don't know what it does, but what it will do right now is it's going to listen for shutdown of XPCOM, and it's also going to listen to a startup cache invalidation, and then we load the archive, presumably the file that we have set up here. So loading the archive means getting at the file, making sure that it exists, and then it's apparently just a zip archive, so we'll load the zip archive. Okay. So we load the archive. We load the zip archive. Okay. Great. So that's everything that initializing I think does, is that it loads, it unzips a file, or it opens an archive which is a zip file that's in the special directory, and then we're done. And it also sets up this observer, the shutdown observer, which presumably this thing is going to do the work of closing file handles. Let's see here. Let's look at the definition of startup cache observer, or startup cache listener, I should say. Startup cache listener, when it observes, we get the startup cache singleton, and then we'll tell it that we're shutting down here. If we're shutting down, we'll say wait on writing it. So make sure we write, and then we tell startup cache that we've initiated shutdown. And if we're invalidating, then we tell the startup cache that we've invalidated the cache. Okay, pretty straightforward. So that's what that part does. And what else does the startup cache do? So presumably there's something that gets things from the archive. So let's see where archive operations occur. Loading the archive is done in init, and then there's this get buffer. So who calls get buffer? Oh, so if we're reading prototype bindings, or for XBL, or reading Zool prototypes, then we'll read them out of the buffer. We'll ask to get the buffer. Okay. So what it'll do when we get buffer, where's get buffer? Sorry, I just kind of spaced out there. Takes an ID, which is like, I think we're using like URIs for some things, and then there's an out buffer, and then there's the length of the buffer, presumably. Let's take a look at a couple of more examples of it being used. Yeah, it's like you pass in a URI or something, and then what we're going to get is a buffer and then the length of the buffer, and it returns a return value on whether or not presumably it succeeded. So we're going to get the buffer. We make sure that we're running on the main thread. And if we happen to be writing to the buffer, then I guess we wait for that to occur. And if a startup write is not initiated, then we'll get a cache entry. So we'll create a cache entry pointer, and we'll create a dependent C string. So a thing that wraps the character pointer, the C string that came in, and we have some kind of table here, and we're going to try and get an entry, a cache entry from this table. So somewhere we created this table. Where did this table come from? Put buffer, can cache close write to disk, write to disk. So after we write, apparently we clear the table. So, or when we invalidate the cache, we also clear the table. So when do we put? Lookup before add. Anytime we put buffer. And then we might measure the size of things. If we have nothing in the table, then we return. So presumably the table is a thing that contains the stuff that we're likely to write, that we're about to write. So when we get the buffer, that's in the event that we haven't actually written to disk yet, which makes sense because startup write has not been initiated. Apparently I'm not streaming to Twitch. What? What's going on? Should be. One moment while I check to see if I'm streaming to Twitch. Apparently I'm offline. What? Why am I offline? Let me, whoopsie daisy, come on. OBS, what are you doing? So if you're watching this on Twitch, sorry, you're not watching this on Twitch. For some reason, I am not streaming to Twitch, and I don't know why. And also, my machine's really sluggish right now. So I'll bring that over here. Let me quickly check the administrative interface for Air Mozilla 2 and see if I can figure out what's going on. OBS is just absolutely racking my CPU. Okay. Let me just quickly open up my email and get that link. One sec. In the meantime, we can still read through this. Okay, so that makes sense. If we hadn't written stuff yet and it's something that's in the cache, then we'll just pull it out of the table. Otherwise, we get the buffer from the zip archive. All right. Okay, so getting the buffer from the zip archive, what that does is it's going to say, if there's no zip, so the archive, the zip archive is marchive, which we'd opened earlier. If there's no zip, then it's not available. Otherwise, I guess zip item, there's like a mapping of item IDs to buffers inside the zip file, which makes sense. Then we get the zip item out if we can find it. So when constructing it, that apparently does the extraction, and then we'll get the buffer and then the length of the buffer. Okay. And if we succeeded, we return our V. Now, there's also the OmniJar. If return, we'll get the OmniJar, which is also a zip file. Let me check some OmniJar entries. Get buffer from, we'll check the zip archive of the OmniJar. And then we'll check the toolkit OmniJar. So failing that, we'll fall back to, if we can't get it from the zip archive, we'll get it from the two OmniJars, which are different zip archives, but those are where we normally load things. So it looks like the fallback is actually, the fallback for there was nothing in the startup cache seems to be implemented here inside the startup cache. So let me take a quick peek here. Like, let's look at the Zool, the XBL binding, or the XBL document, reading the bindings out. Yeah, there's no like fallback here. So startup cache is responsible for not only checking the cache, but then falling back to the OmniJars. Okay, that's good. I can work with that. Meanwhile, how about Twitch? Just have to open up the Air Mozilla management interface. So I'm pulling up the producer tool. I'm not showing this on screen because, well, just in case. Producer tool. I don't know if the producer tool allows me to choose where I'm outputting to anymore. Sources, where are the outputs? Scenes, overlay layers. That is not what I wanted. Where's the monitor tool? Is that what I want? I want to know about where things are going. Panel commands, broadcasting a message, people viewing it. Here, outputs, okay. No outputs listed. Am I, what? Am I streaming to YouTube? I sure hope so. Andy, if you're watching the stream, what's going on? Do you know? Apparently I am streaming to YouTube, but the stream health is quite poor. Which blows. What's the dealio? I can't even see the, yeah, I'm there. I'm in YouTube. But the monitor tool doesn't say that I am. Weird. Alright, I'm going to have to figure that out. In the meantime, if you're hoping to watch this on a different video streaming service, I recommend YouTube right now or Air Mozilla, because I think that is the most reliable source of this stream right now. Sorry. I know Twitch is handy and where you want to be. Alright. So where was I? Well, first of all, very clearly the script preloader, or not the script preloader, the startup cache only runs explicitly in the parent process. Like I'm pretty sure parent, yeah. If we attempt to get it from the content process, we fail. We fail. Part of me wonders if that'd be useful for the but before I do that, one of the things to also note is that like it really is only useful if things have been written to the buffer in such a way that it's like in a optimized format. So like, where is startup cache put buffer called? Well, we'll get like put buffer, right? Cache script, cache, JS loader tools. Here. So we'll cache key info, the buffer. Buffer is from the input stream. Input stream is from what? Input stream, storage stream, storage stream, new object output wrapped storage stream from the output object. We write string, and this is in the prototype cache. Begin caching. Okay, how does it work? Get the Chrome directory. We assume the first package locale is the same as local. Cache entry was invalid or it didn't exist, so write it now. So where is the cache? Like, what is the cached thing? Some kind of local, all right, buffer of the Zool cache info key, buffer, and the length of the buffer. Oh, that's if we're getting it. I don't understand about putting the buffer, put buffer, which is down here. Make unique, that comes from the input stream, Input stream is written to from the storage stream, from object output, get that from locale and Chrome path. Object output is an object output stream. And we get, I think this is the key here. This is actually something that Startup Cache Utils has. And what it does is it knows how to get a storage stream and then output the object well, no, it creates an object output stream and it creates a storage stream. So what are these things? MSI output stream, object output stream. Let's look at the definition. Write object. Write the object whose root or XBCOM identity NSI supports is a object. The cause for writing this object is a strong or weak reference. So the A is strong reference argument must tell what kind of pointer is being followed. To an interface. So we can write some object to as some kind of stream. First, singly and strongly via its root or subclass of its root. We write ID, and then we get the buffer. So the things that are being called on it that are interesting are write object and write, like any of the write methods on the output stream. We write strings, locale, write string Z. That's just writing a string. What does storage stream do? String. Storage stream. Storage stream. Just hooking up some streams here. Oh, then we read. We read from the input stream. Got it. We read from the input stream, which reads from the storage stream. Okay. Storage stream. So this is the interesting thing. Get the output stream, close, flush, write. Seek. Reading and writing. How do you serializing? Serialize internal. That sounds interesting. Storage stream. Object output. Oh, and that's object output. Serialization helper. Reads an object from the stream to satisfy strong reference. Binary stream implements. Compound object. So we'll get information about the class and whether or not it's serializable. So if a thing implements NSI serializable, then we will serialize it and then write that to disk, or write it to a storage stream or something, and then we pipe the streams together, and then we write that to disk. So the things that are serializable all implement something called NSI serializable. What implements NSI serializable? Principles. Zool prototype documents. So there's like a read, object input stream, read an object, and then there's write. And maybe I'm more interested in write. We're gonna write a compound object, the URI of the document, and then node infos, the prefix, serialize the document contents, prototype PI, processing instructions. That's what it is. The processing instructions. Okay. So Zool, here's what I found out. The startup cache is this thing that the parent process has access to, and it knows how to cache stuff in this special file that's outside of the main profile directory, and it will attempt to only cache things that can be serialized with NSI serializable, that implement NSI serializable, and failing to read or write, or failing to read from the cache, we will fall back to asking the OmniJar for these things. Okay. Let's see if there's been any effort to add caching capabilities to normal HTML documents. Serialize. What is core serializers as a component? I should look that up. Bugs following conversion to HTML or plain text during saving or during, oh. When saving or during copy paste. Okay, that's not exactly right. Use startup cache writing is used with Zool to fragment. Templates. Oh, I see. This has nothing to do with the startup cache, I don't think. Let me see if I can find more bugs having to do with the startup cache and figure out where they put them. Log. Oh, Smurfd says he's got to go. He saw that I landed the problems document flush bug fix. Yes, I did. Yes, that all worked out. So, the horns. Thumbs up. Loading order. Interesting. So, where was this filed? Core XPCOM. Okay. Core XPCOM. I'll bet you there are a bunch of bugs in here. Too many to list. Let's see them all. Startup cache. There's 5 matches here. Preload startup cache. Performs many small read. Okay. Cache. There are 23 matches. Get rid of Windows stat cache. Read ahead startup cache. I think I'm actually going to ask hey, do you know if we have any pre-existing bugs for serializing, for adding HTML document support to the startup cache? Or maybe, do you? Okay. The reason I'm doing all this research is because I'd rather use a pre-existing mechanism than build something brand new. The other thing, though, is that even though the About New tab page is loaded in a special privileged content process, you always have to think that it's going to get taken over. Like, it's going to get confused, and it's going to always assume that, you know, you're operating in a hostile environment. So maybe we don't want to give it access to the full, maybe the privileged content process should have its own startup cache. That's what I'm thinking. Okay, so there are no pre-existing bugs there. Okay, cool. Thanks. So, no known ability to cache. Oh, BDAL has played with various approaches for adding XHTML support to startup cache. Let's bring this chat over. Anything interesting? Where did you get to? Because here's what I'm thinking. Suppose when we start up the privileged content process, we hand it a file descriptor for its own separate file, its own special startup cache that it can read from. But we need some way to write to it. This package would be nice to put up somewhere. File bug for adding support. HTML docs, then we'll fix again. We're not doing it. The other quick and dirty thing we could do is just see how much of a win we could get. Like, I wonder how quickly we could hack something together where, like, after activity stream loads, we just jam the DOM into local storage, which I know you're not supposed to use local storage. It's synchronous disk access. But we'd be doing synchronous disk access to read it out of the OmniJar as well, I think. Let's just see. Can we hack together something quick and easy? What's the best way to do this? Is there like an about new tab service? If the document's interactive, we'll load all these things. Where did I read about using a cache, React, Hydrate, local storage? In one branch, I created a parse that read from the prototype cache but fed the normal XML content sync. That branch preserved most of the normal HTML code path but didn't have quite as good performance as Zool. I can take some review. He said. He said, instantly regretting it. I think it was this render caching. Crash state, setup API calls, cache locally the unload handler. Huh. So we could look at that. Oop, more messages about caching. In another another branch to create a new content sync that read from the prototype cache. This better performance, but it looks very similar to Zool, and I think at that point it would be better to load XHTML with the Zool document. Unloaded. Maybe we could try doing it here. Local storage. Set item. I'll just call it cache for now. We're going to JSON stringify. I think this is a good idea where conditions set item. It's actually not in an object. Call it cache and then stringify. I'm not actually going to put the conditions in for now though, but I'll say win.document content. Is that what's on there? Like if I or if I go to about new tab and look at the DOM, what do I see? Whoops, didn't mean to do that. But I can get the body, document body. Document body. Document element. Good, that'll give us everything. Outer HTML. That'll give us even more everything. So I'll get the document element, the outer HTML. And we'll see what that's like. We're going to see if that stores some stuff inside local storage. Just out of curiosity. I can't remember if I'm doing a debug build or not. I don't think I am. I think this is an opt build. Okay, I think I'm gonna have to stop the stream shortly. I can feel my throat starting to get wrecked, but I need a drink. Oh, syntax error, new tab service, line 178. I did it wrong. Right, needed to do that. Whoopsie daisy. Let's try that again. Now when we unload this page, like click on mozilla.org. All right, now let's go back to the new tab page and let's see if we have anything in our local storage. Storage. Cookies, local storage. Nothing. Okay. Writing to cache. Just log that. Dump. Done. Writing to cache. OBS is taking almost 300% of my CPU. It's eating up, and kernel task and Sublime. It's amazing. What is going on? Yeah, like look at this. It's gone down a little bit. So if I browse to Mozilla, huh? And hit this event listener. Document now interactive. Make sure that the privileged content process is enabled. Yep. Nothing. message content process observer. Dump ANTS running in parent process. Let's run mock build faster just to be safe. I wonder if about new tab service, where is this? Components new tab about new tab service. Yeah, I wonder what's going on here. Document now interactive. Well, that's good. So now that we're logging, if I browse away, the unload event never fires. Bailing at 2, dump bailing at 1. All right, one more quick test. I'm a little disturbed. The script preloading stuff that my intern had worked on, Jay had worked on last summer, doesn't appear to be running properly. Or at least if it is, it's running in a way that I don't understand. Saw load event. So it sees the load event here. Never sees the unload event. What? Maybe that's because we're flipping processes. So it is running this stuff, but it's not ever running this stuff. Huh. Well, that's given me a lot to think about. I think I'm going to cap the stream here. Let me write a couple things down. So startup cache will only work if we make it so that it can accept an arbitrary string, probably from JS. I don't think that's likely. something like local storage might be the simplest approach, although this will incur a main thread read penalty. But we'd have done that loading from the startup cache anyways. Perhaps we can find a way of loading the cache off of the disk into a buffer and handing the buffer down to the content process. Do a buffer early on. So that's worth thinking about. Okay, well, thank you so much for watching episode 164 of The Joy of Coding. I hope next week my throat's a little bit in better shape and I have my stamina back. And I will see you next week. So whatever you're doing this week, take care, have a good time, stay safe, stay warm or stay cool, depending on where you are in the world, and bye-bye.
The joy of coding.
See ya.